Hey everybody, this is Larry. This is day 19 of the Leetcode February daily challenge. Hit the like button, hit the subscribe button. Ooh, join me on Discord. Let me know what you think. I got a breed spot. Okay, today's problem is minimize deviation in array. I'm in Colombia's Cartagena, so I've been not gonna lie, I've been walking around a lot, partying a little bit much. So yeah, so this video is coming out a little bit late. Probably not gonna make the bi-weekly, and probably not gonna even make the weekly. But we'll expect to see those videos soon. But yeah. And if you're curious about what I've been doing, hit me up on my Instagram below. That's my travel Instagram, and hopefully I'll have some pretty pictures for y'all to enjoy. And yeah, anyway, also in general, I don't know if have I always said this. I've been drinking a little bit, so I don't remember. But if I haven't, then come hang out in the Discord channel. Let me know how you did or think about this the daily problem, and where people share their code, get code reviews, get feedback, just comment, have fun, whatever people do. There's a good amount of people there now, so I'm really proud of it. Today's problem is 1675, minimize deviation in array. So okay, so you're given an array nums of n positive integers. If an element is even, divided by 2. Element is odd, multiplied by 2. So maximize the difference between any two arrays in two elements in an array. Okay. Let's see. Well, I think the first thing that I would think about is greedy, and not greedy in a way, but greedy in the sense that we're trying every possible things. The thing with one thing to notice is that if you multiply by 2, you can only do that once, right? Because if you do it once, then it's odd. So then that means that for every initial odd number, you can only have 2 possibilities, right? Which is the original odd number or the even number that comes before. Where the even number, you can keep on dividing it by 2 to get it as small as possible. So to minimize the deviation, I think one thing that we'll try to do is divide it as much as possible. I think that's probably a good way to think about it. But another way of thinking about it isn't just greedy to get a final state, but also greedy on not brute forcing, but like greedy and then checking the evolutions of things as you go, right? And the way that I would think about this is that, okay, so you have like almost like you have a bounding box, where you have a bounding box, you take the biggest element and then the smallest element, and that's your deviation, right? So then now, if you have this rubber band, right? Well, if your biggest element is odd, then you're probably done because you can't really do anything with that one. And if you're done with that side, and if your smallest element is even, then you're also done with that side, right? So that's like your final state, probably, maybe, or some variation of it. Otherwise, if your big N is even, then you could divide by 2, right? So that can only have a couple of cases, right? One is that when you divide it by 2, well, now your bounding box got smaller, either by that number or another number that in the middle, in between. So okay, let me actually draw this out a little bit, because I think I'm just saying it with my hands. Actually, you don't even see my hands because I've used the new thingy. But basically, you have the small n, ASCII art, and the large n, right? So if, as I said, if this is even, sorry, if this is if this is even, then you're probably done with the left side, because that means that you can't really get any smaller on the left side anyway. At least not. Maybe that's not true per se. At least not yet, because there is a case where there's a number coming from the inside that makes it smaller. Maybe that's could be possible. But anyway, but yeah, if this is odd, then there's no other way to again, there may be a thingy, but you're done with this number, right? So then the thing that I would do is try to shrink this span. And so I think what I would do is just on the bigger end, because if you do it by 2, it seems more intuitive to minimize the deviation. So then we divided the biggest number by 2 to make it smaller, and then this new the number would like it may the number may be divided by 2, but for example this thing maybe moved to the middle, but there might be another number to the right? So we have to think about that. But it either makes the thing smaller, or this number goes to the left, right? So this is the other case. So then in that case, we just check again to see the smallest number and so forth. I think that's generally the idea that I'm going to play with. I'm gonna yeah, I'm gonna divide. I think for me the intuition is to divide it by 2, because so I'm gonna do all the even operation, I think, or like all this all the even operations. And because you could keep on dividing by 2 multiple times, and also because of division, it makes it smaller, so the derivations get closer, right? Where if you multiply by 2, that's not the case. So I think that's probably the thing that I'm going to try to do. So the first thing that I would do is, I think you should use a heap. That's, to be honest. Using a heap, you keep track of the smallest number and the largest number, and then you can maybe rejiggle it later on, right? What I'm going to do is use a sorted list because I'm lazy. Not going to lie. Yeah. So then now we have the sorted list, right? I think this is Gucci. Okay. I always forget that. Well, maybe not. Maybe I just haven't used it in a while. I think in the past I actually do remember it. But that's why I run it before and making sure that everything's okay. So, okay. So this gives me, well, the input is already sorted, so that's a little bit whatever, but this one, no, that doesn't really matter. I mean, I know how sorted list works, so yeah. And then now what do we do, right? Now, while the last number is equal to 0, this is even. Oh, well, let's do best is equal to right? So that's the maximum difference because that's deviation. Okay, so then now we divide it by 2, right? So then now best is equal to so then we can always keep doing this. And then now after that, I think now we can see if we can shrink the left side, right? So while and this of course is wrong, but because I have to do amend on this, not just setting it sloppy like oh, strikes. What am I doing? Oh, huh. Actually, didn't know that. You cannot set it. I guess that makes sense, actually. Okay, fine. Let's see. Right, same thing here. I don't know if I knew that, but I mean, I think I probably did, but I don't know. Maybe I'm just not remembering it today. Yeah, so that looks good. I'm gonna give it a submit. I could be wrong on this one, but I would like to see. Oh, huh. Okay, let's see. Okay, that is just a big case. Why is that wrong? Is there a mod that I have to do? This is not a mod question, right? Okay, good. Because that would be really funny, but sad. Apparently last time I did, I did it a couple of times, but this, maybe I did something wrong. Let's see, right? Just want to make sure that my code is right first. Because these are the only cases where I can span the box, right? So usually I would analyze this, but clearly, this is a ridiculous like input to kind of be able to run through, right? So or like to manually test. So I was hoping that I would get a wrong answer on this silly one, but Let me see if did I make a wrong assumption? We keep on dividing by two. They should have okay. Well, I guess there's only one thing to really. What the? So if you get my output is this, and you could there is a smaller answer. So that's the thing I'm trying to figure out is right how to get the smaller answer. So you only really need to care about the biggest number and the smallest number, right? I mean, until you update it. Wow, I guess this one. I thought this is it, and or like something close to it. So maybe I'm a little bit off by a little bit. Well, the first thing to do is see if I can have a smaller case that is wrong, but I mean, I knew that I wanted to do it. I just was a little lazy, to be honest. Hopefully this is wrong. Nope. That's good. That okay. I mean, it's a smaller case, but I guess it's not a small enough case. Same answers as before, though. So what I'm trying to do now is get like the smallest case that is still wrong, so I could. Yeah, same answer. So something weird about this. Wow. I mean, but this is so many. I'm doing like a bisection of sort. Try to figure out how to do it, but it's a little bit tough. Huh. Okay. So it's still wrong answer. That's good. Incrementally, this is slow and painful sometimes, but that's how you learn. But I don't. Why is that? Why is this wrong though? That is what I want to know. Okay, I mean we're making progress. Sorry if you're here hoping for a short one. I don't know what I'm doing wrong, so that's why sometimes. I mean that's the problem with this greedy problems, where we talk a lot about greedy problems, and sometimes greedy problems have these kind of things where you think it should be good, but you're wrong. Um, uh, so it's this big thing, but I'm trying to figure out why. I mean, this is so many numbers. Let me see if I can think about this logically. Why this is small. Um, hmm. Try to come up with a smaller counter example as why. Um, hmm. Sorry, friends. I have disappointed you. Oh, why? Tell me why. Oh my god. This is ridiculous. Oh, and why? Okay. So this strategy hasn't been going well. It's some interact. Usually it's just about like two numbers or something, right? So okay, let me try a different tack. Let me try to print SL at the very end. Okay, so this is this sorted list. Okay, that didn't help. Okay, let's do it without the sorted list, I guess. I'm sitting on day C, so I'm getting. I think I'm gonna get a code or something. But okay. So this is the wrong answer, which is good. Or at least it's consistent. So this is what we think is best. And at the end, we have this number, of course, because we multiply them. What is it here? Well, we just divide it by 2. Let's see. Huh, so the smallest number was already even, and the largest number is odd. How do we get a smaller number then? Huh, am I missing something silly? Largest number is... the smallest number is even, so you're not gonna make it any smaller. Huh. I guess that okay. I guess I'm just wrong about my assumption. I think this is the case where um I guess this is the case where let me try something out really funky for a second. Will this return the right answer? Yeah. Okay. Hmm. How do I generalize it though? I guess that the thing that I was wrong about was that um you can actually I guess I did say that a little bit earlier on that because you can only do it once, you might as well do it later because then this will later take care of it. Okay, maybe that's a better idea. I don't know. Let's see. Let's give it a submit real quick. Yeah. Okay. Yeah, I mean, I think the idea is that, and I think I was thinking about this, but I think I just confused myself and try to. I think that this is one thing about experience, right? Is that sometimes you think you can simplify things, and I think that's what happened here. Is that I prematurely optimized, not logically, or not like people when people say that people usually mean like performance, etc. Well, but for me, I think I was just trying to like skip a step without really thinking it through. And in this case, the reason why you want to do it, what we have here, is because um, in is that if we multiply all the odd numbers by even, right? then when this step is done, the smallest number will be even. But also it means that if the number that we multiply by 2 becomes too big, this will bring it back down anyway, back to the original number. So in a way, it is reversible, where if you divide this by 2, it's not always reversible. So because you may make a number too small, right? Like for example, maybe you have like, for example, if you have something like 7 and 8, you might make the 8 a 1, and then you just like messed up, right? Like I know that maybe there's some nuance about how I did it, but yeah, I think there's some like, yeah, this makes sense. So what's the complexity, right? Well, the complexity is going to be n log n, because for each number, maybe log n isn't quite right, but for each number we add and remove log n times, right? I think I'm just mixing n as y. So let's just say n is equal to number, or you go to length of nums, and let's just say what was it for a? Always you go to range of numbers, right? Which is integer, which is 10 to the 9 in this case actually. Then the algorithm is going to be n times log n times log r, right? Excuse me. The reason why this is the case is because for each number that we have, each operation is going to be taking log n times, and for each number we do log all of these, right, up to, because for example if you have 2 to the 32, you can divide it by it 32 times, right? So that's roughly the idea behind this complexity. And then for space, this is going to be linear space for the sorted list. I think sorted list is linear, right? If I'm wrong, then I'm wrong on that one. That's my bad. But you can also use a heap for the same, basically the same idea. Just have to be keeping track of it. That's all I have for this one. This was a little bit sloppy. I think I jumped a little bit ahead and I missed a point, and I couldn't figure out how to debug for 9 minutes. Yeah, what did I do last time? Okay, so last time I did use a heap. Yeah, but I mean this one was the wrong answer. How did I get it right? I get it right by fixing it to do. Oh yeah, so I fixed it by doing this, I suppose, by making all the odd numbers even. Yeah. Past Larry is smarter. All right, how about the second time I did it? Same idea, I guess. Wow, and both times I used a heap. It's just that I times it by 2 first. Past Larry is so much smarter. I don't know. The last couple of days I've been a little bit off, I suppose. Yeah. Anyway, that's all I have for today. Let me know what you think. As you can see, I don't know. This has been a really weird week, but that said, I'm having a good time here in Cartagena. So it is what it is. Thanks for watching, though. Stay good, stay healthy, to good mental health, and I'll see you as soon as I can. Bye bye.